Okay, more functions. We are almost ready. Trace is the next function that I want to show you. That function is pretty easy and it's just a mix of two functions that we already know. The trace simply gives us the sum of the diagonal of a matrix. So sum of diagonal now equals trace sum matrix. Let's run it and we get an error because my matrix is not a square matrix. Now, this is one of the shortcomings of the trace function, that it only works on square matrices. Now, here we have a 5 rows by 6 elements matrix. So let's just delete one element from each row. So we are deleting one column like this, alright. And let's run it. Sum of diagonal is 11. Is it 11? So sum matrix. So 1, 3, 2, 2, 3. So here we have 6, 10, 11. Yes, it is. Now you can take the sum of the diagonal by doing this. Sum of diagonal, no, 2 equals to sum of diagonal of some matrix. It will produce the same result. Now, as I said, the shortcoming of this function is that it only works if your matrix is a square matrix. That is not true for the second way. The second way works with any matrices because let's see it. There we have it, 15, so some matrix, the diagonal of some matrix. We have seen this function, we know what it does. Will give us the diagonal regardless of the size of the function, and we can even shift that diagonal. We know this, so we can shift it by 3 and we will get some other diagonal, but we will also get the sum of that diagonal. Now the trace does the same thing. The trace will give you the sum of the diagonal only if the matrix is square. Now next, so this is diagonals. Next we have the rank of a matrix. Rank of a matrix, pretty simple. Simply use the rank function on a matrix, and there you have it. The rank of our matrix is 6. Determinant, calculating the determinant. So determinant of matrix equals that of some matrix, and there it is. By the way, this will not work if we use a non-square matrix, so we can get the determinant only of square matrices, as you can see here. Now, let's move on. And finally, inverse matrix. So, inverse matrix equals to the inverse of some matrix. The function is called inv. Run it, and there you have it, the inverse matrix. It's a big matrix, but there it is.